So starting with total pressure and center of pressure. As we have discussed in the morning also, total pressure is uh, a force or pressure that is being exerted by liquid from all sides on a particular immersed body. We talk about the whole pressure that is being exerted by the liquid, we call it total pressure. And center of pressure, just like moment of inertia and that center of gravity. The center of gravity or CG of a body lies at a particular point where the whole of the mass is being assumed to act. Similarly, center of pressure is the whole pressure that is acting on a particular body is assumed on a particular point, and that particular point is called as center of pressure. Now we have to calculate total pressure and center of pressure in different types of bodies: horizontal plane surface, vertical plane surface, inclined plane surface, and curved surface. That is on your screen. So let me show you the first three diagrams of what horizontal surface. The horizontal surface is like this. When you talk about vertical surface, that will look like this. When you talk about inclined surface, this is the inclined surface, this is the surface, and this is the cross section of that. And similarly, if you want to talk, if you are going to talk about the curved surface, this is the curved surface. So this is the four cases that we have to do, and let's solve the sum for center of pressure and total pressure. Now, starting with horizontally immersed surface, let us a flat plate of negligible thickness is being immersed horizontally in some liquid. Right? Take a plate, a horizontal plate that is immersed inside a liquid, and that is shown on your screen. Right? This is horizontal surface, and it is y distance away from the free surface. This is the liquid surface on which the liquid is being surface is being immersed. Now, this is the diagram, and A is the area of the immersed surface. This area of this particular element is called area of the immersed surface. YC, depth of the horizontal surface from the liquid surface. The top surface to this up to which it is being immersed, as we have done in the previous article, Z distance from the surface. In this case, we are going to take YC distance. Then W is specific weight of the liquid. Then the total pressure on the surface. P is the weight of the liquid above the immersed surface. Then that is equal to specific weight of the liquid into volume of the liquid. Then specific weight of the liquid into area of the surface into depth of the liquid. Now, if you want to calculate the total pressure on the surface, that is equal to specific weight of the liquid into area of the surface and into depth of the liquid. To multiply these things, you will get the total pressure in case of horizontal surface. The most simple case is for horizontal surface, in which total pressure is equal to WAYC. W is specific weight, A is area of the surface, and YC is how much deep it is inside the liquid from its free surface, right? So total pressure is equal to WAYC. W is specific weight, A is area, and YC is the distance up to which it is being immersed inside the liquid. So next is vertically immersed surfaces. Vertically immersed surfaces. The previous one was like this. When we are talking about, it was horizontal surface. Then the next case is when it is this vertical surface being immersed inside the liquid. So let me explain this on first on your PPT, and then I will do it on board also. Right? This is a bit different and difficult part that is to be done. In this case, we will take a random shape body that is being immersed inside a liquid. This shape is random shape, any shape, a rectangle, sphere. Now in this we have assumed a small strip of thickness dh, right? Then let us assume that the center of gravity g, center of area of the surface, it is assumed that it is two-dimensional body. So centroid of that particular figure is at g, and p is, we are assuming that center of pressure of this particular liquid, that is p, it is located at this side. We have to calculate the value of P, that is H star. We have to calculate H star, how much it is away from the center of pressure is how much away from the free surface. We have to calculate that. We have to calculate H star, the location of the center of pressure from its free surface. B is the center of gravity or centroid, and P is center of pressure. H bar is the distance of center of gravity from or centroid from free surface, and H star is the distance of center of pressure from free surface. The thickness or the width of this particular element that we have assumed is B, and H is the distance of this strip that we have assumed from its free surface. Right? Now consider a plane vertical surface of arbitrary shape immersed inside a liquid as shown in the figure 3.1. A is the total area of the surface. The total area of this particular surface is A. G, thus G is center of area of the surface. We also call it centroid. And H is the depth of the center of area. Now this H is how much D plus area is assumed, DH area. Then OO is the free surface of the liquid. This surface is called OO and it is free surface of. P is the distance of center of pressure from the free surface of the liquid. In this article, we are going to calculate H star. Right? Now, pressure intensity on the strip P, as we have done in hydrostatic pressure, P is equal to rho GH. As I have done it in the morning. Curly P by curly Z is equal to P rho into G. And if you take differentiate this, P is equal to rho GH or Z. So that is being used over here. P is equal to rho GH and area of the strip dA. If you want to calculate this small area, dA is width into the thickness of this, d into dh. This will result into area. Now df, pressure into area. df force, the change of the force, small change in force is equal to pressure into small area. This is pressure is rho gh that we have calculated for hydrostatic pressure into P, B into dh. This is area. Now total pressure force on the whole surface is, if you take it a small force, we have taken small area. So small force will be there. If you want to calculate the whole force, we have to integrate this. So GH into B into DH, we are integrating this. Now when you integrating this, B into H into DH, this rho and G are constant. Rho is density, density remains constant. G is again a constant that came out of this integration. Now B H into DH. Now B H into DH, in which B into H, B into DH is dA. You can write it H into dA. Now this is called as moment of surface area about area of the surface into distance CG from the surface. A into H bar. This can be written as A into H bar. And this now this equation becomes that this rho G is there. You can call it rho G A into H bar. Now this, if you integrate H into dA, now this is equal to area of the surface into distance of center of gravity from the surface. Right? If you integrating H, it will result into center of gravity of the free surface. So A into H bar. H bar is the center of gravity of free surface, the distance of center of gravity from free surface. So A into H bar. Now integration of H into dA is this. Now putting the value of H into this H into dA in this equation, you will get F is equal to rho G A H bar. Now this is the force in case of total pressure force. Total pressure force acting on this particular vertically immersed surface. Now let us first write this in the board also. Then we will move to the next part of this article. Let me erase this first. Now first of all, we have to draw this diagram. That I have drawn this diagram. Now small surface consider dx. Its thickness is dx and its distance from the free surface is h, and the thickness of that, the area we have considered as b, or width is b, and these points is G and P are, center of gravity is G and center of pressure is P. The distance of center of gravity from the free surface is taken as h bar, and center of pressure from the free surface is taken as h star. Now, once you have drawn this, what is to be done is we will first calculate pressure, and pressure is equal to rho gh according to the hydrostatic law that we have done in the morning. Now, dA is small area, the small area of this particular step. dA is L into B, that is equal to dH into B. BDH is the small area of this particular step. BDH, right? Now, TF force, small force, that can be taken as pressure into dA. We have calculated pressure rho gh into dA BDH. I hope it is clear to you. Rho gh is this hydrostatic law accordingly, and then the area that we have calculated as BDH, that is to be written over here. Then after this is dF, and you can integrate this. Rho gh and BDH, on integration, this rho g will come out, and you are left with d into dh into h, and this ddh is equal to dA h into dA. Integration of h into dA is equal to A into h bar. Now F is equal to rho g A into h bar, where h bar is the distance of the center of gravity from free surface. The integration of h into dA will become equal to A into h bar, and this A is area, total area of this figure, and h bar is the distance of center of gravity from the free surface. If you have questions, you can ask me. Okay, let's move to the next slide, or center of pressure. Before moving to center of pressure, let us take first pole. Let us resume with the center of pressure. As I have told you that center of pressure is the point where whole pressure that is acting on a particular body is assumed to act. So we have to calculate that particular point. The point through which the resultant pressure acts is known as center of pressure, and it is always expressed in terms of depth from the liquid surface, how much it is away from the free liquid surface. Now, first of all, in this case, to calculate this h star, that is written on the board also, the distance of center of pressure from free surface. To calculate that, you must first of all calculate the moment of force we have found acting on a strip about free surface. First of all, you have to calculate the moment. Moment is force into the vertical distance. This it is acting this. This is the small this area that we have considered. The force is acting on this area. So the perpendicular distance is h. df into h. df into h. that is moment for the force. Now df we have calculated in the previous this total pressure. We have calculated the df, that is equal to rho gh v into dh, pressure into area. Rho gh is pressure and vdh is the small area, and h is for this moment particular. Now the sum of moment of all such forces about free surface of the space. If you want to calculate the sum of the moments of all the forces, then you have to integrate this